Hi Matt, this is the second video out of our lesson 2.4 about the sine and the cosine ratios. So in this question, we're presented with this information here that the length of the hypotenuse of a triangle is 3 and the length of the opposite side, as it refers to the angle I'm looking at there, theta, is 1.4. So we could have been asked to do this in our last couple lessons where we're using the tangent ratio, but to use the tangent ratio I would have one problem, and that is that I don't have the adjacent side here, I don't have the bottom. But given that it's a right triangle, I suppose I could use Pythagoras and then use the tan ratio, so 3 squared minus 1.4 squared equals x squared. Solve for that missing side, find out that it's, gross decimal, but 2.65 something something units, meters long. And then I would be able to say, okay, well, tan of theta should be equal to opposite over adjacent. So tan of theta should be 1.4 over that 2.65 number. And I get that theta should be about 27.82 degrees, depending on what they asked us to round to. There is a better way, a way more efficient way, and that is why we learned in the last video about these other trig ratios. So this question is way better done with the sine ratio. Since sine ratio refers to the opposite divided by the hypotenuse, and we have both the opposite and the hypotenuse, we could say right away that sine theta must be 1.4 over 3. So inverse sine of 1.4 over 3 takes us directly to that answer in one step. So no Pythagoras necessary. Not every question needs to be done with the tan ratio. We do have sine and cos as well. So here's another example of a question where, okay, we've got this triangle, we've got two sides given, and we're asked for the measures of both angle A and angle C to the nearest tenth of a degree. So we want both of these other angles here. There's no reason to find the missing side. No one's asked for it, and we don't need it. If I want to find angle A, I can look at those two sides and say, okay, one of them is adjacent, and one of them is hypotenuse, and cosine is the ratio that relates adjacent and hypotenuse. So cos of A should be 4 over 7. So if I solve, cos A equals 4 over 7, inverse cos of 4 over 7 tells me that angle to the nearest tenth is 55.2 degrees. Now I have two choices of how I find angle C. One would be to just say, oh, well, the angles better add up to 180. And so I know two of them, 55.2 and 90. And so find the missing angle, and it's 34.8 degrees. So that's a no trig ratio necessary way. Or if I just go back to the triangle and I say, well, for angle C, the two sides that I have are opposite and hypotenuse. So sine of angle C should be 4 over 7. And if I solve that, sine of angle C is 4 over 7. I also get 34.8. Neither one of those is particularly time-consuming or onerous, so whichever one makes most sense to you. But to start off, you will need to use either a sine or a cosine ratio to get yourself an angle there.